Really? Get me like that? Can't remember if we did this already on the calculator. Well, let's talk a few things about the calculator real quick. I didn't bring them with me, but that's why I turned you around. Okay. Interesting video. So it's 25, right? Specifically?
Yeah.
Yeah. I like it.
Minus 198x plus 1080 equals 0.
This is this is number 25 and 5.3.
Yeah.
All right. So if you have your calculator, play along. If you don't, look on somebody else or just watch me. This is up. This is on your the calculator Bible again that I gave out a while back. So almost everything that we do in here that's related to calculator, try to find it on the handout first. And the book does a pretty good job of giving you step-by-step instructions on how to do it in these calculators. Shoot. Took the wrong one. Go away. All right. So let's put this in here. X cubed. So you say x to the, a little caret there, to the get third power minus 3x squared. What is it? Minus 198x plus 1,000 freaking 80. Can somebody tell me what's the y-intercept for this function before you even graph it?
1080.
I like it because when x is 0, the function is 1080, right? Now we're trying to force the function to be 0 and see what x has to be. And x could be several things. How are we doing? Everybody got that in there okay? And when you graph this, you should expect it to maybe look kind of funky. What's up?
I get the x squared.
Yep.
And mine just came up with a little 2. Is that okay?
Yeah, sure. Oh, I see. Well, the x squared really doesn't mean x squared. It means square whatever you've written. You have to kind of write the x first. Of course, I just totally screwed up with it. I'm here for you.
Is there a way to, because you know how yours wraps? Mine doesn't wrap.
Oh, you got one of the new ones.
Yeah.
That's one of the features I don't like in the new one. You got to like push the arrow buttons over. I think this is better because you can see the whole thing.
Exactly.
Yeah. But, oh well. They got to make it way out, right? They made some things better, so they have to make some things worse. Now, if I hit graph, we're all going to get funky stuff because I don't remember where your windows were set from last time, right? So if I hit graph, actually, it's not too terrible, really. If we all hit zoom 6, what should happen? Zoom 6. What should happen?
It does the standard.
Then we'll all have exactly this picture here, right? Okay.
Did you put equal in the equation?
No, it's in there already. See, there's the equal sign. You cannot put into this equals to some number. It's going to graph the entire function for us. Then we can go see where it equals 0. Right?
It didn't do anything. Hers said error too.
Oh, what kind of error? Oh, see, there's no explanation.
You missed the 3 before x squared.
3x squared.
Oh, I'm sorry.
And
Thank you.
1 negative 20.
X cubed minus 3x squared. Okay. That's good. I like you guys so much. Yeah, please tell me when to make a mistake. It's fine. You don't have to tell me like that.
Erasing the whole thing.
Huh?
How'd you do that? Without
There's an
erasing?
insert button right above delete. So you just move around and then you can insert.
Should I put it on the x or on the minus?
Put it on the X because insert will push that over out of the
Okay.
way. Yeah.
Yeah.
Cool.
I just noticed it because
So I mean,
my
those
graph-
arrows and these insert delete buttons are just like on a computer. I mean, when you're doing Word or whatever. I don't know if you ever use that, but if you hit the insert key accidentally, that's when it sucks because it starts overriding shit instead of moving it aside, right? I don't know if you guys have ever done that. So if I hit graph now, let's hopefully it looks almost the same. So that's I can see one answer already. I mean, where's the answer that I can see?
The X intersection.
Yeah, right there, because I'm trying to find out when is this function. 0 is 0 right there for one thing. The problem is the higher the power gets, the higher the biggest power gets, the more turns this thing could have, right? And its y-intercept is freaking 1080, so it might go up to 1080 and come back down, and then over here it might go down and come back up. I don't know. It can have, at most, one less turn than this. How many turns does a parabola have? It's the second power. How many turns does every parabola have? How many turns? One turn, right? It doesn't turn again. That would be a cube.
Yeah.
So a cube can have 1, 2 turns. A fourth power can have 1, 2, 3 turns. Are we doing all right? Do you guys see? That's a cool general rule. All right. So a couple ways I can kind of tell where to set my window possibly. One thing you do just to see what it gets. I normally hate this, but let's just try this. Zoom, fit. The last option, zoom fit. Just hit zoom and hit the up arrow. Some of you guys might have a longer list here, but find zoom fit. For me, it's 0.
I hit zoom 0.
Okay, cool. Just not sure if it's in the same place for everybody.
Tuning anything.
All right, zoom fit, enter. Now see how this sucks?
Yeah, it looks
It
really
sucks
good.
for us. I mean, it looks nice. I see a lot more of it, but do I see what I need?
Nope.
But I get a good indication of what's going on here. There's another answer going to be over here somewhere. Cool. And there's another answer going to be over here somewhere. Right, because it's turning around, maybe it's going to hit the x-axis again. Another thing I do a little more direct is, you remember the table? If I hit second graph, and I look at the table, I can see where it goes to 0. I might even be able to get the answers if they're not ugly. Do you see how they got big and now they're getting smaller? Following, of course, what we saw on the graph, which was now gone, but the graph kind of started going back down over there. So it's going down, 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 and actually my answer's there because these are nice whole number answers. If they weren't whole number answers, I'd at least see about where it changes sign, maybe where it gets really small, and I want to make sure that I can see that on my picture, on my graph. So if I wanted to see that 0, what would I go change? So I could see that 0 show up on the graph. What would I change? So I could see it.
You change the x to like negative 20.
I like it. The x mid. Right? I can't see far enough down. Going back to the graph real quick. I can't see far enough down to see it. And at the same time, you might as well change this x max a bit, right? So let's try that. If I go to window.
Whoa.
Oh, what's up?
My y minimum is negative 216.8047.
Oh, yeah. I like
and
it.
the max is 1976.
Mine too. Right? Some of you guys maybe were born in 1976. I don't know what that means. So let's see. We need to change the x min and the x max, right? So I can see those places where it hits the x-axis.
Ooh, cool.
So if we make the x min, like you said, negative 20, let's just go ahead and make the x max 20. What the hell? Keep it nice and symmetric. It's probably going to be too far, but too far is better than not far enough. I'm starting to look a little bit more like my friend here, right? So my friend here would have 1, 2, 3, 4 turns. Actually, this is not planned. I just wanted to wear the shirt. I'm like, all right, it works. 1, 2, 3, 4 turns. So what would the power be on that possibly? A fifth power. A fifth power would have maybe 4 turns, up to 4 turns. Does everybody get that idea? It's kind of a cool idea. And it makes sense, because if it's a second power, I expect at most 2 times for it to hit the x-axis. We get 2 answers, and we've seen that already. We've solved x squared problems equal to 0. We get 2 answers. We got 1 answer once when it only sat on the x-axis, right? Or we might get no answers if it never hits. But if at most it can have this many answers, then it can only hit the x-axis 3 times. It can't turn any more than that. Hits it once, twice, 3 times. It can't turn it. If it turns again, it's going to hit it more times than it's allowed to. So that's why it makes sense that the little rule, 1 less than the power. All right, go ahead. I don't think I've shown you how to find a 0 yet. Have I? I showed you how to find an intersection, right? And they ask you 3 questions. So you're the same thing. They ask you 3 questions. And I'm going to show you a way to do it every single time, because on the calculator, left and right gets a little weird when you start thinking about the answer, because we always got to think about the x-axis. And they're going to ask me a left bound, a right bound, and then a guess. You see what it's doing? It's giving itself a place to search, and then a guess, and it's going to look for that 0. That's the idea. So here's a way to always do that correctly, right? So if you hit, where should it go? Where did we go to do like a intersection between 2 lines? Yeah, exactly. Go second trace to get to calculate. Second trace to get to calc. Now which one of those do you think I want to do now?
0.
Yeah, exactly. I want to find the zeros of the function. One thing you guys are going to hate is you can't find all 3 zeros at once. Another thing I notice here, if I want to find that 0 or even that 0, do you see how this writing is kind of in my way? How can I kind of alleviate that problem? Well, that's a suggestion. The writing is overriding where I want to see. So what I want to do with this whole thing, I want to
Shift it up.
yeah, which means I want to make y min bigger and more negative. If I pull this down, it's going to pull this whole thing up, right? So if I go into window and I change my y min even more than this, I want it to be. Let's make it negative 300. Let's see what that does for me. I don't know if it's going to be high enough. Let me see. It's not quite high enough. So go back to window. Let's make it negative 400.
Change the wrong one.
Yeah.
All right, maybe that's high enough. Let's see. No. Screw you. Let's go to window and make it
For you.
negative, say 700. All right, that should be good. All right, let me come back. All right. So if you kind of lost me there, go to window, make y min negative 700. Just so I can have that writing down there and still see what I want to find. Right? That kind of sucked. They've had the writing on top of my intercept. That sucked. So I just picked the whole thing up so I can see it a little better. All right, so make that negative 7. Remember, there's a minus button and a negative button. Make sure you hit the negative button. If you hit graph now, it should just be lifted up. Whoop. See, there's a lot more room here. So where I want to go again, I want to go to second trace to get up to calc. And I want to calculate the 0 of the function. So let's get this one first over there. You can only do one at a time. You can't get it to give it all to you, right?
Okay.
So if I want to get that one, here's the process you go through until you get more comfortable with this. Before you do any entering, you're not going to answer this question yet. You move the cursor right on top of it. And you don't do anything else. Just move the cursor until it gets right on top of that bad boy. That's exciting. All right, it's about close as I can get. Right there. Get as close as you can get to it, right? I don't know if you guys really see this yet, but trust me, as you do some of these, it's going to come out. That left and right get a little freaky, especially when you want to keep hitting up and down to move around. So I say get right on top of it, as close as you can, left bound, hit the left arrow 3 times. Then you're definitely on the left side of it, right? No matter what the hell the function is doing, all this weirdness, you hit the left arrow 1, 2, 3 times. Enter. So that's like the left wall. Now we're going to set up, we're setting up, see how I opened an arrow up there? So we're going to set up the other wall, and it's going to say, okay, I'm only going to search in here then. So it doesn't freak out and give you something you don't want. Let me do that again.
I got you, I did what you did, but I don't understand what you just said.
Oh. If you don't give it a small enough region to search in, the algorithm that it uses to search could freak out, right? Because it's really neat. Well, you don't learn it until calculus, what it actually does, but it kind of like gives a guess and then looks at the slope and then gives another guess and looks at the slope and it kind of like narrows into it like that. If you don't give it a small enough region to check, it could slope itself out and freak the hell out. Well, it goes crazy. So you want to give it kind of a small little area. It's in here, right? So now I want to go right bound. So you go right back on top of it again and hit the right arrow 1, 2, 3 times. And then for your guess, incredibly enough, you put it as close as you can. Give it a good guess. Cool. Now in this specific problem, you can just go to table. If you go to table, why does it make sense now what I see in the table? Does everybody get that okay? You want me to do that one more time, or is that cool?
I just have a question. Is the root, is that 0?
The root is another name for the 0.
Okay.
Cool. I like it. Is everybody cool with that little process? Did you guys get that? We'll do it again for this other one. But if you look in the table, why does it make sense what I see now? We're at negative 15, I see 0. So you can actually answer this entire question, entirely from the table because the answers happen to be whole numbers. If they weren't whole numbers, I wouldn't see a 0 there. If the answer was negative 14.87, I'd see a really small number there, but not 0. Then I'd have to do it the left bound, right bound guess, because then it can calculate the exact answer, not a approximation, right? Are you guys semi with me? Maybe. Okay. Let's do another one.
See, it's going to do it differently.
Back to your graph. We're going to find this one now. Second
What was the guess?
trace 0. Move that bad boy. Remember, don't sit there and get frustrated hitting up and down. You stupid cursor. What the? You know, left and right moves it up and down would hop it to another function. I don't even have another function. That's why it's just sitting there saying, what do you want me to do? So move the cursor right on top of what we want. Come on, little dude. There he is. Now hit, it's asking left bounds. Hit 1, 2, 3. I'm definitely on the left side. Right bound. I get right on top of it again. 1, 2, 3. I'm definitely on the right side. And then guess, get right on top of it. Now I get 6.
Guess gets right. Ours do upper a little bit.
Now if you didn't bring your calculator, if you don't have one yet, I highly suggest you get a hold of one after class sometime and try this exact problem out, because you've seen it working now. So try this problem out, and then you actually hit a few in the homework that ask you to use a graphing calculator, and they have answers like negative 7.18246. So you have to use a graphing calculator.
No, no, no.
Hmm?
No, we're doing upper, so you can
Okay.
do above that.
Is that all right?
Just gonna go over here and do the
You can do that if you want. And then you get right under 1.
Oh, yes. So the last question is yes. Get it as close as you can.
There you go.
Enter. Fall off, poor little dude.
Can't.
I think what you did was
Enter.
you didn't give it the right. So the left bound.
You can do it.
You're right back on top. Right bound 1, 2, 3. Now it's going to search in between there. Yes, get right on top. So when I open those little arrows, you want to make sure they're both pointing towards each other. If you do like this, the calculator says, what? I want you to look between here and here. Oh, what? I can't do that, right? So you got to tell it between here and here. It says, okay, cool. I'm going to look in there. Make sure the arrows are pointing in. Let's do the last one. Why not? Repetition is key here. Second calc 0. Go over here to the last one here. You're right on top of it. Hit left 1, 2, 3 times. Enter. Get right back on top of it. See how it opens that arrow? It's pointing this way, thank God. Then hit right 1, 2, 3, enter. Now it's going to search in between those 2 arrows. Now give it a good guess, so get right back on top of it again. Enter. And there it is. Cool. Okay. So that's how you find the zeros of a function using a calculator. Can anybody tell me, now what 3 zeros did we get here? We got,
15, 6, and 12.
so for this we got the zeros were negative 15, 6, and 12? Can anybody tell me, what does that say about this itself? What does this tell me about what this does? There's a few different answers to that. There's a specific one I'm looking for. Obviously, if I put a negative 15 in, this whole thing becomes 0. I mean, that's what we forced it to do, right? What I'm looking for is something more like this. How does that thing factor? X plus 15? Because wouldn't negative 15 make it 0? You guys remember this? I said this a few different times, a few different ways, because that's the connection between where you see it hit the x-axis. That must be an x-intercept. That must be where the thing is. That must be a factor of the damn thing, right? And what else must be a factor?
Negative 6.
X minus 6, x minus 12. That's how you factor that bad boy, right? Can you tell just looking at it? No, it's not very obvious, right? But now after I've done this, I can see that's how you factor it. Right? Okay. Not an easy one to factor, I don't think. No. Because what is 15 times 6 times 12? What is that, if you do that? 90 times 12.
Yeah.
And 80.
Do you guys see that? So you do get x cubed, right? X is x cubed. This times this times this is 1080. And if you multiply the rest of that crap out, it all boils down to this. It's kind of nifty to see it going both ways. We solve an equation by factoring it and getting these, or if we got these, we know how to factor it. The course has got to work both ways. Okay. Here's something even a little more interesting, maybe. Let's say I wanted to solve this equation here. And I'm going to make it purposely easy just because. Right? If I wanted to solve this by hand, what would you do? Yeah, subtract 10x. Be careful now, this is where everybody tries to make this harder than it really is. Take an x out. X minus 10. So the two answers would be 0 and 10. Now I could put this into y1 and do the whole 0 thing we just did, right? The more interesting thing is I could put this into y1 and this into y2 and find their intersection. Because where are those two equal to each other? Where their graphs meet, right? And the intersections are a lot easier than zeros. I can just put in the answer, go enter, enter, enter. Do you remember that? I don't know if you guys remember that. So if I put in there x squared into y1, I get to see you guys are all like, shit, man, it's too much for a Monday morning, but hold on. X squared into y1, and the other equation 10x into y2. Graphically, the answer must be where they meet, because that's what it's trying to tell me. I want those things to be equal to each other, right? The problem is my window's freaky, so of course, whenever I put brand new stuff in, I should always hit zoom 6.
Does this still have something to do with the 0?
Well, indirectly it does. Couldn't I, are you guys cool with the fact that I could put this in to y1 and do it the way we just did? Mm-hmm. Right? Get the zeros of this. Or I could put this into y1, this into y2, and find the intersections.
And then we'll get the same answer?
You have to get the same answer, yeah. So already I can see one answer. Where's that line hit the parabola?
0.
Right there. The other answer is going to be off the page here, right? So what do I have to change in my window?
X and Y. Or your Y max.
My y max. I want to be able to see further up, right? So just to be on the safe side this time, let's hit y max and make it
1,000.
Man, it's a little overly safe side. Let's make it 100. Why not? And there you can see it, right? Right there in the very corner. Do you guys see that? So maybe to be even a little more safe, I want you to get used to this window idea. is way up in the corner. So let me kind of pull it back in a little bit. Let me look a little further up and a little further over. So let me make x max maybe 20 and y max maybe 120. And that'll pull it back a little bit more into the middle of the screen here, right? That's what window does for you. If you can't see it, you can kind of tell where it is, and you can move the window there. And if it's too much on the edge, you can just push it a little further out so it pulls it back in a little bit. I can see it a little better. Now remind me, how do I find the intersection? The intersection is really nice.
Table.
Calc.
I could do table, but it might not be a nice answer. I made it nice, but I could have made it ugly.
Second.
Go to
Trace.
second trace to get up to calc. And of course, intersect. Now we went through the whole thing. I don't know if you guys remember, if I hit enter, it says for the first curve and the second, it automatically balances for me. So the shortcut is put the cursor on the answer, enter, enter, enter. Right? Because when I hit enter, it bounces to the other curve. Enter, so I just told it what the two curves are. My guess, I'm already there. And there's the other answer, x equal 10.
I'm sorry, when you went to trace, which one did you go to?
Oh, what are we trying to find? We're trying to find the...
Zero.
No, careful. I got two functions. I'm trying to find the intersection. So number 5, yeah.
And then press enter.
That's right. Put your cursor right on top of the answer you want. Enter, enter, enter. What does this have to do with my equation? This here. What's it have to do with my equation?
Nothing.
Nothing. I like it. That's the correct answer. It's part of the point where those two functions meet. My equation only cares about the letter x. So I just look at the 10, and of course we already got the 0 where they met. So 0 and 10, exactly like we got by hand. Cool. Now some of you guys are out there, you didn't quite get my point. You're like, well, why the hell would I do all this shit? It's easy by hand, but not everything can be done by hand, right? So you want to know how to find it graphically. In fact, there are some things that are impossible to do by hand. And we've developed more visual ways of answering those questions, right? It's kind of nifty. Yeah.
And how are you making sure, like when you arrow it up, how do you know for sure that you're on the right spot?
You don't know for sure because you can't get there exactly, but you just get as close as you can. Right? Make sure that it looks pretty good, that you're as close as you can get.
Oh, just
Oh,
for that.
notice so second calc 5. So it should be on the line now.
Curse
Right?
the old beast.
So see how the cursor's on the line?
Oh, okay.
And then just get rid of it there. And then hit enter, enter, enter.
Throwback edition.
There you go. Cool.
Came up with that.
Sweet. Some of you guys might realize every single equation could be solved like this, right? Any freaking equation I give you. X blah 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 equals x blah blah blah. Throw both of them. Y1 is this side, Y2 is that side. Find where they intersect, right? I've just given you like this monster blanket way of checking every equation you ever do. You guys follow me? Sort of? I don't know. Okay. Yeah, that's really nice. I'm just so ecstatic about it. No, it's Monday morning. I agree. All right. So enough of that stuff. So that's cool. That question kind of led me into what I wanted to do here. Any other questions from what we did last time? Yeah.
5.6, number 50.
Okay, cool. Let's move the chair. Let's see. So this one just says factor.
Second.
Now don't just blurt out the answer. What's the process you go through? What's the first thing you look for? I don't know.
Greatest common factor?
Yeah, you look for anything that comes out of everything. And is there anything that comes out of everything? Yes, there's an x squared that comes out, right? No number comes out, there's no y's here, but they both have at least 2 x's. So what's left here? I like it. So you move that the hell out of the way, right, first. You actually could do this without doing that first, but you have to do it at some point. You'll get two things, and one of them will have x squared in each. You have to be able to pull it out then. What am I left with? What is this? How many terms are there? So it can only be what or what? Yeah, it could either be cubes or squares. I like it. So it's definitely not cubes, because 16 is not something cubed. 121 is not. Everything can be cut in half. So what do you say? You say, thank God. Or you don't, I don't know. But remember, this guy comes to the right. You know, I'll never say thank God in this line. And then how do you do this? Difference of squares, 16 is? Yeah, and the x4 is x squared. So 4x squared, 4x squared. Minus plus, I like it. 121 is 11, y4. And the other half goes over there. That's why it's a thank God problem, because you just cut everything in half. Once you identify it as this difference of squares, you say to yourself, thank God. I don't care how much shit there is in there, you just take each piece, cut in half. Half there, minus plus.
It'll cancel out when you do
It automatically builds that, okay, whatever's this is also here, whatever's this is also there. So the middle terms automatically have to be the same, different signs. So the middle terms, by construction, cancel. That's kind of cool. You're forcing this thing to do what you want it to do. It's kind of nice, because a lot of times you feel powerless in math. Here you're like, screw you, man, you do what I want you to do. So you're forcing the middle term to die. Cool. Yeah, and then back here.
5.4, number 75.
Okay, cool. I like this. Sandra, the little know-it-all, says that she will never miss a point of intersection. She will never miss where two things meet, because she always uses this big old window. She always uses negative 100 to 100, negative 100 to 100. She'll never miss any point of intersection. What, of course, is silly about that?
They can intersect outside those bounds.
They can intersect at 200, right? And then, Sandra, you're screwed. I mean, that's kind of silly. So that's the point there, is you can never make a window big enough to catch everything, because it could meet one further than what you set it at, right? So you just got to, like we did, we looked at the table, we looked to see where it looked like it was turning. We have a lot of different ways to figure out how big a window do I need to really catch everything, because if I make it too big, my graph looks like, right? So I don't want to make it too big. Yeah. Is that cool?
Cool.
Yeah.
Okay.
That's the point they're trying to make, though. I don't know. Sometimes people read that and they read too much into it.
I still haven't got my mind around the concepts of these negative 100, 100. I mean, I understand it in the window now. I'm learning it in the calculator, but there's just been so many in the past that I'm just like, huh? Like, which one matches? I'm like, huh?
Do you guys see my mindset
Erasers.
That sucks a lot. Let's see what this does. All right.
Use mine.
What's that? Oh, all right. You just randomly carry around with it.
No, remember, I was a tutor. I always had to have markers and.
Thank you. I've been spoiled, so hey. And you continue to spoil. Okay. I'm not exactly sure. You know, when we hit that zoom 6, it goes negative 10 to 10 on both axes, right? So she's saying, well, she's going to make it 100. So she'll catch every point of intersection, but of course the point is they could intersect
At 200.
way up here somewhere, or way down there somewhere.
I understand that. It's just, I mean, I guess I need to go back a couple chapters, because there was a few problems where they're like, well, which window should they use where they can see the intersects?
Exactly.
And I just got really lost on those.
Well, that one was, I think people read that too much to mean.
I think I was probably reading too much into it, so I guess you can ignore it.
I feel like I'm living in the unless there's a park again. What are you people doing? That the one you're talking about, I remember that one. Was they gave you an equation or something, and they said, you know, what window would you be able to find? And you just solve the bad boy, and you see what they are, and you tell them, you know. So the one option was -10 to 20 for the x-axis, and then x-min to x-max, and I don't know, -30 to 50 or whatever for the y. I mean, would you be able to see both answers using this?
No.
Because if you solve it, one of the answers is going to be 25, and you're not going to see it. Yeah, that was the only point there, was to. It's a little easier than it sounds. You don't actually have to pick up a graphing calculator at all. You just solve it and see, does it fit in the options they give you.
I mean, now that we've practiced on the calculator, it makes sense to me, and I'm so new to get it, but I'm like, God, if we had done this calculator before, I would have gotten it then.
All right.
Okay.
No, I agree with you. It's easier once you actually do a problem all the way out, instead of them asking you, if you were holding a graphing calculator, what would you have to do? Yeah. Oh, all right. So I think, yeah.
Somebody else.
65 on the same page.
Yeah, that's the one I got stuck on.
Oh, all right. We actually did this problem, not exactly this problem, but we did exactly what they're asking. If you graph this thing, and you see the little picture they have, the little graph picture. Whenever you see that little red picture there, that means you must use a graphing calculator to do this, right? So if you graph this and go through all the steps you went through with that earlier, x cubed minus 3x squared. Remember this problem we just did a minute ago? So blah, blah, we did all that mess to try to fit it all on there. And once we got the answers, weren't we able to factor that thing? Okay, same thing over there. It's saying factor this by looking at the graph. So if you graph that bad boy, you're going to see, I don't know, something. You're going to notice that the answers are going to be way back here. Right, so if you graph this and you zoom 6, you should see something maybe like that. That's what I'm guessing. Because the answer is going to be way back here. They're really big negative. Right? So if you put that into Y1 and hit zoom 6, your graph should probably look like this. Is everybody doing that for me? No?
Mine is like
It's not in the window.
I don't know where mine is defaulted to though.
That's all right. Your window is the same as it just was a minute ago. So yeah, if you hit zoom 6 though, it won't show up. Right? So then you got to change the window so you can see further back this way. If the answers were -30 and -17, let's say that's where it hits, how would you factor this?
X plus 30.
Good?
X plus 17.
Yeah. See, that's what they're asking you to do, right? That's not the answer, by the way. But if it was this, that's how you would factor it. So you go find, where does it actually hit the x-axis? And then you just write x plus blah, x plus blah. That's how you factor it. Yeah.
And how do you find those numbers?
The way we just did this one.
Can you say it one more time? I mean on the graphing calculator.
Yeah, so now you hit second calc, 0. Remember that? And then you that's the left bound, the right bound, the guess.
Go to 0 or first go to number 2?
Oh, so yeah, number 2 for the 0. You're trying to find the zeros of the function. So just like we just did this problem here.
Okay, so where it says x equals 0 and then it says y is 3/84, then that's what the answer is?
That's the y-intercept. You want the 2 zeros. You want the places where it's the x-axis. So remember, this is where you go. It's asking for a left bound. Let's see, where are you? Here. So here comes your cursor. So you're going to that one. Remember that you put it. So again, you put it right on top of the answer as close as you can get. Hit the left arrow 3 times. Enter. Get back on top of it. Right arrow 3 times. That'll be your left bound and your right bound. Then you put it right on top for your guess. The whole process we just did a minute ago with that one.
Maybe I'm like special ed, but I'm not understanding that part at all. I'm not special. I know you're saying it over and over.
This is brand new, but I'm trying not to bring it back up on here again, but I could. All right. had, let's see, x squared. What was it again? What's
X
the
squared plus 40x
Thank you.
plus 384.
All right, so there it is, right? Oh,
No.
I guess I should turn that on. I'm so happy they're doing that right now.
Hey, me too.
Okay. I don't know if that's a custom right there. All right, so there. You guys cool? So I put the equation in there. Now just to show you again, if I hit zoom 6, because I don't know what the window could be really, and it just happens that the last problem we did happened to have a good window. Are you always going to be lucky like that? No. So at the moment, I really have no idea where the hell this thing is. So again, if I go to table, I can kind of get a feel, oh, I happen to be back here already, but I can see that's where the 0 is, and that's where it kind of, it's negative here and positive there. Right, so I can kind of see where it's supposed to be. So I want to be able to see that far back. And actually I can see it build and then turn back around again. Now again, on this problem you can see the answers. And on a lot of these problems, they're going to be whole number answers. So you can actually get the answer from the table. The zeros are negative 24 and yeah, negative 16, right?
So, because I'm going on my table and I don't see any zeros anywhere.
Does your table have negative 17, negative 18?
It has, as far as negative numbers, it's those, that's what it looks like.
Oh. You're borrowing this from somebody, right?
Yeah.
Oh. So if you go to table 6, it says the 1, 0, start at 0, step by 1. So now you have 0 instead of, see how it's going bigger that way? So moving up the valleys, smaller, smaller.
Oh, okay.
Yeah, so you can see.
So do that every time I
There's
do
your,
it?
yeah.
Okay.
So this is exactly like making an XY table on your own. It's just a lot quicker, of course. The answer won't always be a whole number, but if you see a 0, hey, shit, there's the answer. I don't even have to do the graph really, right? But if you don't see zeros, then you're going to see like 9, negative 0.13, negative 10. You know, that's trying to tell you it's in there, in between there somewhere. So let's just pretend like that's not a 0 for right now. I can see it looks to be in this area here. There's another one even further up, right? So I want to make x min maybe all the way down to negative 30, let's say. So if I make x min, go to window, makes x min negative 30, graph, now I'm seeing far enough down that I can see both intercepts, right? Because from the table I saw that they were in the larger negative region, so I want to be able to see that region on my graph, right? Now you could, if you had to, you could go do the left bound, right bound guess, the 0 function, right? Hit second calc, or second trace to get to calc, right? Do the 0 function to find that. In this case, we didn't need to because we already got the whole number answers from the table.
And if we do that, if we do that and we find about where it's at, you'll take that as an answer?
If the answer is not a whole number, you have to come in here and do the whole left bound, right bound guess, and it will tell you 5.89234.
Okay.
And normally I'll tell you on a test rounded to the nearest 10,000th place or something, right? Because normally if it's not a whole number answer, it could very easily be some really ugly forever answer, right? Okay. This kind of thing just takes practice, and I have assigned you some things in the homework that ask you to use a graphing calculator to get in there and do exactly these kind of things.
So if I had negative 16,
What do you want us to put?
make it.
Homework, so just like the answers that I can tell your kids
No, that's the
Yes,
you're right
pretty
about
much.
that.
You could also, if you want to,
These are
sketch a graph of it real quick, but
Application, but the
I'm I'm going to take your word that you're doing it, because on the test, I'm going to ask you to do it, so you should probably do the practice.
So,
Yeah.
negative
So
16.
on a test day, I'll bring the calculators in case yours run out of batteries or whatever, you can borrow it. Because I am going to ask you specifically, use your graphic calculator now to do this. Right? And you can bet that I'm not going to make them all whole number answers.
Aw.
You're so kind.
Yeah.
Negative 16, 0. Just figure
You're
why
good?
that's what you had already.
Yeah.
Hopefully you'll be going over 5.6, number 55 and 65. Pulling out those factors, OMG. I'm like, when do I do this?
So 55,
And 65,
In section 5.4?
5.6.
65 is not too bad.
No, 65 is not too bad.
Oh, I'm sorry, wait, I'm looking at 5.5. 5.6, right? 55. Okay, cool. All right. So this is what I'm talking about. Now we've talked about the basics of the different forms of factoring. Now I can go back and fill in the gaps about like special cases. And there's not too many special cases, thank God.
And I figured you'd probably go over that.
Yeah. Before we get into that, any other questions from? Yeah.
If you have to factor out an equation, so you end up with x minus 1, x plus 1, and you write the x is equal to plus or minus 1.
I love it.
That's
That's
fine.
beautiful. I love it. So she's saying that if you get like x minus 3, x plus 3 equals 0, you don't have to say x equals 3, comma, negative 3. You just say x equals plus or minus 3. That's beautiful. Right? But I always love it when a student comes up and says, where's the plus minus key in my calculator? There's no plus minus 3. Okay. It's like the any key. Press any key. Where's the any key? Okay. All right. So, the question right now is this one. I like it. Minus y squared. You very quickly, hopefully very quickly, notice that if you try to group this and this group and that group, because obviously there's 4 terms, there's no GCF, 4 terms means grouping. If you try to do this, you run into trouble quickly. Here an x comes out. Here maybe you could do differences, but then if you do difference to squares maybe, or there's nothing GCF, what the hell can you take out now? You're like, damn it. So this is a special case, right? Either they gave it to you out of order. Maybe that's supposed to be there, but there's no way. If you can try a few different orderings, it's not going to work. There's nothing that's going to end up as uncommon. Or instead of doing a group of 2 and a group of 2, you're going to love this. You do a group of 3 and a group of 1. Because what do those 3 look like? Isn't that a trinomial? Isn't that easy to factor? I like it. Yeah, you do x minus 3, x minus 3. And now you guys are like, that doesn't look any better, Jeff. Thanks for that. Well, what is x minus 3 times x minus 3? X minus 3 squared. All right, now let's see if you guys can handle this. Y is something I don't know, right? What is x minus 3? Something else I don't know, right? So this is something squared minus something squared. So what form is it in? Difference of squares. Because there's only 2 terms. Okay, maybe. So if I had this, how do you factor a squared minus y squared?
That's why.
You put one a there and the other a there. Minus plus, I like it, one y there and the other y there. Do the same damn thing here, right? How many x minus 3's do I have?
2.
So can't I put one of them here? And one of them here? And how many y's do I have? Got a couple, so I can put one there minus and one there plus. That's the whole thing. This has come up a couple times where this is one thing. It's 2x minus 3. So this here, x minus 3 is one thing. Just like y is one thing. So if I have 2 of them, I can put 1x minus 3 there and 1x minus 3 there. There's even a method called substitution where you say, let's make this a. And then I factor it. And what was a? X minus 3. So I put an x minus 3 there and I put an x minus 3 there. There it is. I replace what's really ugly with just a one variable. It makes it easier to look at. Let me give you an example of that. Here's a good example of that. What if I had this one really particularly looks ugly. Now you could foil it out, get your like terms together. You're not gonna have like a lot of like terms because there's y's in that one, right? So it's gonna make it worse if you do that. Here's one way you can do this if you want to. One way you can do this is to let a equal 2x plus 5 and b equal y minus 7. Now, the minute I start doing that, people freak out. But do you see why I'm allowed to do that? I mean, why do we have variables in the first place in algebra? When I'm doing a word problem, why do I bring an x in?
To work with the unknown.
To work with the unknowns. What is 2x plus 5? I don't freaking know. Let's call it a. Because I don't know what the hell it is. I can call it a. That's what variables are for, aren't they? Now, it's not cheating as long as the answer you end up with doesn't have any a's or b's in it. They're just there to make it look better. If you stop with just a's and b's, that's no good. I'm going to go, what the hell's that? I had x's and y's. What the hell's that? A's and b's? Shit. So here, how do I write this now? What's that? So a squared minus b squared. Now look, that's freaking nice. It's the same stupid problem. It's the same exact problem. How do I factor that?
A plus b, a minus b.
What is a?
2x plus 5.
What's b? Y minus 7. What's a? 2x plus 5. Now here, you got to be careful. You got to remember. Minus b, so minus y minus 7. And I'll just clean it up a little bit. And you're done. The main thing to realize there is 2x plus 5 is one number. It acts just like any other one number thing would act. That's why I can replace it with an a. Because it's going to act the same way. The a is just a placeholder for it. It makes it easier to look at. That looks a hell of a lot better than that did. Even though some of you guys realize they're the same stupid thing. I don't even have to do this step, do I? I got two of these. One there, one there. I got two of these. One there, one there. Minus plus. Now I just clean it up a little bit here. I get 2x plus y minus 2, right? Just put your like terms together. Here you get 2x minus y plus 12. I like it. I may not do that because that's, but you bring the negative through and then you can put your like terms together. Okay, maybe.
That's longer than that one looks like.
Which one?
The answer is longer than the question.
Oh yeah, I know. And think about it. Each of these could foil out and bring in all these terms, right? That's why it's not too weird that it's this long, because if you foil this out, it'd be the same as foiling each of these out and you have all these terms, wouldn't you? So they're still equivalent.
You accept that for an answer?
Yes. Because that's done. You're done there, yeah. Alright, any other specific questions? Okay, so let's do this. I want to do a little bit of group work today to make sure everybody's kind of like on the same page with this factoring thing. This will be due, and it's going to come out of the chapter test. It's going to have all the different forms of factoring kind of mixed up. Right? So I would like it more if you actually got together with some other people and worked on this. If you desperately want to work by yourself, that's fine. Right? This is going to be page 435. So 19 through 34, and then 39 and 30. So this is due by the end of the day or sooner. Any class work. Oh yeah, that's kind of a boring part.
We're just doing
I
it
should
for
just
like almost
I'll videotape you guys. This is cool. That's how I can take attendance. Just videotape who's